Now move on to the topic scattergraphs. Scattergraphs is something you should already have met in the broad general education, and the reason we might need to draw or want to draw a scattergraph is if we have two sets of data and we'd like to kind of show a relationship between the two or plot them both on the same graph, then a scattergraph becomes useful. Now, we're going to show you three different types of correlation. Correlation basically means a relationship between a couple of things. If there's a correlation between two things, we say there's a relationship between those two things. And what we're looking for, first of all, is to show you what positive correlation would look like. Now, the definition of positive correlation is that a high value for one data set is connected to a high value for the other data set, and vice versa. A low value for one data set would be connected to a low value for the other data set. So things that might have a positive correlation, a connection in this way, might be like this example here. The amount of rainfall and the level of rivers, how high the river level is. So, for instance, a high amount of rainfall should be connected to a higher river level. A lower amount of rainfall should be connected to a lower river level. So, over here on this graph, we'll kind of try and show you what that would look like. So, say for instance, I take the example there. We've just got this graph labelled at the moment with A and B. But I'm going to put in here, we'll say rainfall on one side, on one axis. And up the side here, we can put in river levels. So, if the rainfall is low, in other words, on this scale, it's down towards the bottom end of this, we would expect the river levels to be also towards the bottom of this, and that might be represented by a point of data down here somewhere. So we can see this has a low rainfall and a low river level. A high amount of rainfall up here might be connected to a high river level. So over there, the two of these would meet around about here. So again, I could have that plotted, and what you'd find is they would end up with a pattern like this. So when we have a pattern like this, where we have values moving in a kind of a line almost, upwards from left to right, that's something which shows a positive correlation. As the rainfall increases, the river level increases as well. We'll now move on to look at a negative correlation. What might that look like? So a negative correlation is basically when a high value for one set of data is connected to a low value for another set of data. To give you an example of this in real life, as the temperatures go down, heating bills go up. That's what you would expect to happen. As the temperature outside gets colder, people use more heating and therefore their heating bills go up. So if I was to try and plot that over on this graph here, at the moment I've only got A and B, but let's add these two values in. So we'll say temperatures along the bottom and heating bills we'll put up the side here. And we can start to add data to that. Now, in a month where, say for instance, the temperatures were very low, so on this scale down here at the bottom of the temperature scale, you would expect people to be using a lot of heating and therefore their heating bills to be quite high, so high up on this scale. So a low value on the temperature scale would correspond to a higher value on the bill that you pay for heating. So your point of data might be up here for 1 month. In a month that was much hotter, so for instance along here, the temperature is very hot, you would expect people to use less heating and therefore their bills would be a lot lower, so the point of data might be down here. And what you would get with a negative correlation is this idea of almost a line of data going this way. This is what a negative correlation would look like. Again, the points of data form almost a line that go downwards from left to right. This is, when we're looking at graphs and we're asked to spot a correlation, this is what I would look at and see straight away as being a negative correlation between the two things. As the temperatures are increasing, going this way, then the price of your bills are going down the way. And lastly, we'll look at this one here, no correlation. We have two sets of data. Sometimes we plot them against each other, and actually there isn't any connection between them, and we can spot that sometimes from the graph. Here, the values of A of one data set have no connection at all to the values of B, the other data set. So for instance, something like a person's earnings, how much they earn on a monthly basis, plotted against their shoe size. These are two things we wouldn't expect to be connected in any way, shape or form. So over on the graph, the data wouldn't really form any kind of distinct pattern or distinctive pattern. So what we'd end up with is a very random collection of points. So when we look at this and we see actually there's no kind of clear line that was there in the negative correlation one or the positive correlation one, but it's just a kind of random scattering of dots. This is some we'd say, well, we can't spot a connection there, there's no correlation. Again, correlation just means some relationship between the two values. When you're doing statistics, one of the most important things to remember about this is just because you can spot a correlation on a graph doesn't necessarily mean one thing causes the other. In the two examples we used earlier of negative and positive correlation, one thing did have probably an effect on the other. In other words, there was correlation, therefore there was maybe some causation. One thing caused the other. Just bear in mind when you're doing statistics that spotting a correlation does not necessarily always imply causation. In other words, because you spot that pattern doesn't necessarily mean always that one thing is caused by the other.